Okay, we're going to discuss what we covered in our last CNC class, which was on peck drilling. So we're going to start off with several codes here. We start off with the G83, which is the code, which is a can cycle for peck drilling. All peck drilling is it comes down with a drill, comes down to a certain level, goes into the workpiece and back up, and then it goes down again until it gets to where it was, an additional level, and then back up, however many times you tell it to do it. The G83, like I said, calls up the can cycle for peck drilling. R is our retract, and so it's going to retract to 100 thousandths. My total depth is right here is Z minus 0.6 or 600 thousandths of an inch. The Q tells us how much we're going to drill into the workpiece each additional time, which is 125 thousandths or 1/8 of an inch. And F 1.25 stands for feed rate at 1 1/4 inches per minute. And here it also describes the same thing I just told you. R is the distance of a safety point above the work surface. Z is your total depth, and that has to be a negative number. Q is the depth for each pass, and F is your feed rate. This is the part that we're going to do on the CNC base. We're going to start off at hole number 1. We're measuring from the center of the circle. So with this bolt hole pattern, it's going to be a 4-inch. So from here up to here, it's going to be 2 inches in our y-axis and nothing in our x-axis. To get to this hole here, if we take 360 degrees, which is our circle, and divide by the number of holes, which happens to be 8, that's going to be 45 degrees. So from here to this pie or triangle here is going to be 45 degrees. To get to the next one would be 90 degrees. This one to our 4 o'clock position would be 135. Straight down is 180, and so on and so forth. Let's minimize that, minimize this, and find a better looking print here. There. Now, it shows us right here in this view we're a 1/2 inch thick. We have a 6-inch by 6-inch square, and the bolt hole circle is 4 inches. So that's telling us that the center to the outer edge is going to be 2 inches. So now if we take the calculator, pull up a calculator, and we need to find out what the sine and cosine of the angles are. In our x-axis, or our horizontal direction, we're going to be working with sine. In our vertical, or our y-axis, we're going to be working with cosine. So we have already established from center up, that's going to be straight up, so that's going to be y-axis 2.0, and x-axis is going to be 0. In order to find out what the next hole would be, we would have to find out what the sine of the angle was in our x and the cosine of the angle in our y. So we know that it's going to be 45 degrees. 45 sine equals this number times 2.0, which is our radius. And so it's going to be in our x-axis 1.4142. I can go ahead and put that in right here. And that would be x. Well, let me just clear that out. And we'll do it on another piece of paper here in just a second. 1.4142 is our x-axis, and our y-axis. If we clear that and we say 45 cosine, which is going to be just, let's see, 45 cosine times 2.0, we're going to get the same number, 1.4142 or whatever. We're just going to round that off at 4 decimal places. So both the x and y is going to get that same value. Now if I clear that and we find out what the next hole is, hole number 3, then we can say 90 degrees, because we have to add another 45 to that. So from here to here, it's going to be 90 degrees. So 90 sine equals times the radius of 2.0. Now we have 2 inches. So from here to here, it's going to be 2 inches in our x. And if we clear that, and I say 90 cosine, which happens to be a 0, times 2.0 is still going to be 0. So that means that we only moved over in our x-axis, but y is straight, and it didn't get a value, or the value happened to be 0. Now to get to this hole here, we're going to say 135. So if I clear that out and say 135 degrees sine times 2.0, I did something wrong. 135 sine times 2.0 equals this number. Remember that number again. Now, if I hit my cosine at 90 cosine, no, not 90, 135 cosine, notice it's a negative number here, times 2.0. Now we have the same number, but it's a negative value. So that's how we came up with these numbers. I'm going to minimize this and pull up CNC base. This is the program that we did, and here's all the values. So the first thing we do to get to point number 1, which is the 12 o'clock position, it showed we rapid traversed G00, 0, X gets a 0, Y went up 2 inches, and Z went within 100 thousandths of the surface. Line 6, we pulled our tool down to the surface of 0. We fed down to the surface. We called up the peck cycle, G83. We told it Z minus a half inch, which the total depth that we're looking for. We rapid traversed up to the surface of, or retracted, I'm sorry, 100 thousandths above the surface, and Q was 100 thousandths. That we went down 100 thousandths per pass. G80 canceled the peck cycle. We picked our tool up 100 thousandths above the surface, and then we positioned ourselves to point number 2. So we did the same things, pretty much copy paste between each one of these. All of this is same as this here. Nothing is changing. The only thing we're changing is the direction or the location for each one of the points. So if you all will take a look at this, I will send the code to you via Campus Cruiser, and you'll be able to take a look at what we actually covered. I think most of you got it in class, but this right here will be something you can use as a study guide. To make sure that this continuously works, what I can do is I can open this up to a larger screen, and I'm going to hit the simulation. I'd like to slow it down first so you can see the passes and verify the program. It goes from home to first hole number 1, goes down until it goes all the way through 5 passes. Then it goes to hole number 2, 3, there's hole 4, hole 5 is at 6 o'clock position, last hole, and it completes the program. Normal program stop. What we're going to do come Tuesday, we're going to be looking over subprogramming, which is a program within a program, and it simplifies the amount of lines that's required to do a complex program. I will send you a little information on that as well, and that's the end of the video.